And we're going to start off with a story. The story that we're going to start off with is of a very famous mathematician, Gauss, born in about, I think, 1777. So this is a while ago, and my story is probably not completely true because I wasn't there. But the legend or the story is that Gauss was entering school, kindergarten or grade 1, about 5 years old, and the teacher gave the students the following problem, thinking, this is going to take my grade 1s forever, and I don't know, read the newspaper. They probably couldn't play on his phone because it was 300 years ago. But he can just relax and have his coffee at his desk, and the kids will be busy all morning. Because he said, I want you guys to add up 1 plus 2 plus 3 plus 4 plus 5, and then keep going until you get to 100. And we're also imagining things aren't quite the same back then. You don't have paper and pencil. They might have had a piece of slate and some chalk to work on, so they'd be erasing and adding and erasing and adding. It was probably pretty messy. And the idea was, when you were done and had your answer, you were to bring it to the desk at the top, for the teacher, and all these slates would be stacked up, and the teacher could check them afterwards. And after a couple of minutes, Gauss brought his slate up and put it on the teacher's desk. The teacher didn't even check it. They're like, whatever, this kid is quiet, the kid is nice, they're not going to cause a problem, so didn't worry about him. And then afterwards was going through all of the answers, and they were all wrong, except in less than 5 minutes, Gauss was able to add up all these numbers as a 5-year-old. He's a pretty impressive, considered one of the best mathematicians who have lived all time. Just a couple of other little stories about Gauss. One time in Europe, they were tracking this comet or something, and something happened that someone bumped the telescope, and all of Europe couldn't find this comet. And Gauss was like, so it became like a puzzle across Europe. Everybody's like, can anybody find this comet again? We were tracking it through the sky, and now it's gone. Okay? And it was very far away. So if you're trying to see something through a telescope very far away, if you just move it a tiny little bit, you're going to miss. And Gauss was like, okay, well, let me look at the mathematics, and calculated how the Earth is going around the sun and how fast it's rotating on its axle and how the path of this comet and traveling in an ellipse and different gravitational pulls. And he's like, you know what? Why don't you put your compass right there? And they turned it right there, and there was the comet again. Some other things. Sometimes these great mathematicians in their day were like, I don't know, not socially the best kind, I'm not sure. But there was another mathematician at the time who was quite famous, I think. I don't remember, can't remember the name, but this other mathematician came to Gauss and said, I think I've discovered something really, really important. He gave Gauss the paper, and Gauss read through the paper, and he said, you're right. And then went to his filing cabinet and pulled out a paper. He said, yeah, I wrote about this 17 years ago, but I just didn't feel like publishing it, even though it was a major discovery. So here he was, a great mathematician. Legend has it he could count before he could talk. I don't know if that's even possible, because don't you have to talk when you count and different things like that. So the question is, how did Gauss add these up quickly? What did he do? And there's some different ideas that we can look at. The idea that I'm going to show you is that if I added these up and said, this is equal to the sum, would you agree that if I decided to add them up backwards, I would get the same answer? That's no problem. It's not too amazing yet, right? Ooh, 1 plus 2. Well, I can't do that, but I can do 2 plus 1. No. Adding up numbers in one direction and adding them up backwards doesn't matter. Now, the interesting thing happens is that if we look at adding it up forward and adding it up backwards, and add 1 plus 100 would be 101, and 2 plus 99 is also 101, 3 plus 98 is 101, and you kept on going, and on this side, would you agree if you added them together, that would be double the sum? And now we can easily do, well, more easily do the mathematics. How many 101s are there? 50. There's going to be 50 after, yeah, first of all, here there's going to be 100 of them, right? But that's 2 sums. And then if you divide by 2, or some people take it and flip it around and do half the numbers and half the numbers, divide by 2 and you get 50 of them. And 50 times 101 is 5,050. Still pretty impressive for someone who's like 5 years old, right? So this is the story of Gauss, and it leads into our next thing that we're looking at, which is arithmetic series, where you take an arithmetic sequence and add them up. So if I wanted to add 5 plus 8 plus 11 plus 14, I could add it up backwards and find the pattern of everything that's happening, and we're going to be able to figure out a formula for this. So when you only add up a part of a sequence, you get a partial sum. And we're going to write a formula for this. And the formula for the partial sum, and watch what happens. Watch what happens even if the numbers aren't. I add them backwards. You see they all add up to 19. So the formula that we're going to, one of the formulas, we're going to have a couple formulas, but one of the formulas we're going to make with this is we're going to say, if you add up the first one and the last one, and depending on which one you're adding, so this would be S4, because I'm adding up 4 terms. If I want to find S4, then my last one is term 4. If I want to find S7, then my last one would be term 7. If I want to create a formula and say Sn, then my last one will be Tn. Now I add them up. They all become 19. I would have how many of them? Well, if I'm finding 4, I'd have 4 19s. If I was finding S7, I would have 7 of whatever number it adds up to. So we're going to take this, multiply it by n, because that's how many you have. For 4, I have 4 of them. But that always adds it up twice. So we're going to divide by 2. And on your next page, you have that formula, and it is on your formula sheet. Was anybody not here yesterday when we got our formula sheets? And there's a second formula because, and they've shown it right here, and it's in your notes above as well. So if you have a highlighter, we have a Tn formula from our lesson the other day for any arithmetic sequence. And since Tn is equal to that in any arithmetic sequence, we can replace it in the formula. And that will allow us to have a second formula for the sum. And just a little note that we can do, why do we have two formulas? This formula is nice when you have the first and last term. And this formula is nice when you don't have the last term. Both formulas will work, but sometimes you won't know Tn, so then you might like to use the other formula. So what we're doing in this unit is we're really getting to use a lot of formulas, okay? I hope that the diagram that I showed you at the beginning with adding it up twice in two different ways really shows you where the formulas come from. They're on your formula sheet, and now we can go and do some questions for adding these up. So determine the sum of the first 6 terms. Okay, this is what we want to find. Question, do we know what the 6th term is? Yes. Okay, so we could use this formula. Do they list all 6 numbers? Yes. Would you have to use a formula? No, you could type those 6 numbers into your calculator and get an answer that way too. We're going to practice the formula because if they said add up the first 60, you don't want to be typing in your calculator the whole time. But yes, for this one, definitely, you could get the answer by just adding and subtracting the first 6 numbers. But if we did use the formula, and because I know term 6, I could find the sum of the first 6 ones. There are 6 numbers there. The first number was 25. Term 6, 1, 2, 3, 4, 5, 6, is negative 30. Divide by 2. 6 times negative 5, divide by 2. And we get the sum of the first 6 terms to be negative 15. That's how we would do it with the formula. Okay? If you use the other formula notice has T1, and instead of Tn has a D, you could use the other formula because you might notice that our D value is that we are going down by 11 every time. Okay? So you could use that other formula. The other formula has more things to plug in, and it's bigger. So if you can use a simpler formula, you would like to. But both formulas would work, and of course on this one, you could just add it up. So I just want you to circle one question after this one. It's number 4.